Hi everybody, it's week 10, and this week we're going to add unit testing to our MVC Music Store. So we're going to talk a little bit about what unit testing is. I know some of you have done it before. We're going to do it within a .NET context. So this is from a developer called Derek Smith. I'm just going to go through a few basic concepts about unit testing, and then we're going to look at how do we integrate this into the Music Store, and then how do we do this in assignment 2. I love this quote. It kind of sums up well what unit testing is all about. So the idea of unit testing basically is to reduce errors in our code, to allow us to catch errors earlier, and also for maintainability, that when we make changes to our code, it gives us a quick and easy way to make sure that each individual function we've already written hasn't been broken by updates to our change. So unit testing is kind of one kind of testing that's done, and it's at a very granular level. So unit testing means we are testing each individual component, typically one method at a time within an MVC application. And then kind of we have a larger set of tests called integration testing. So that's where we do things like see how does our application interact with our database, how does it interact with third-party APIs, for example, our Google login, our Google login API, and then user acceptance testing, where we put the application in the hands of our end users and let them try it out. So we're really focused on this core, this unit testing. That also means we're going to have to temporarily divorce our MVC Music Store from our database. So we'll talk a bit more about that. So we're really looking at testing individual methods, and then even within a method, we might have multiple unit tests because different things might happen within that one method. So typically for a test, we want to test each individual thing that would happen in a method. So for example, if our method runs a query and returns a view, we probably want two separate unit tests, one to make sure that our query fetches what it's supposed to, and another test to make sure that it returns the view that we're expecting. So what we're going to use is this kind of framework where they overlap. We have our production code already. We're going to need to rewrite or refactor some of that code so our application can also run unit test code. And then we're going to use Microsoft's built-in test runner. It's called MS Test. There are some other testing tools that we can use as well. So this is built right into Visual Studio. So NUnit is a popular third-party testing framework we can use. Here are some other ones. So it's basically going to look like this. We're going to create some test classes, and then within test class, we'll write individual unit tests. And again, it's one test per unit, but again, one method may have multiple unit tests. So this is kind of what a unit test might look like in a test class. So we have a descriptive name for the test. Zoom in a little bit. And we're basically passing in some fake data, and then we're calling a method, and then we're checking if the result that we got is the result that we expected. So this is kind of what we're going to do. So we're going to unit test, wind up unit testing one of the controllers. And so basically the way a unit test works is there's 3 steps. The last step is where we use a method called an object called Assert. So Assert allows us to check what are we expecting this test to happen. And typically we can check that our results is either our results are true or false, that something is null, or we can compare that the value we get from our method is equal to the value we expect. So we typically want one assertion for each test. So what we'll do is we will create a test controller that will match one of the controllers in our web application. Then when we do unit testing, integration testing, we're testing across layers, but unit testing is testing one layer at a time. So one model, one single controller at a time. And we're going to use mock data because we need to be able to divorce our controller methods from the database temporarily. We need to be able to mock up our data instead. So we have a NuGet package we're going to install called mock that's going to do this. And then we can use a test runner to run our tests and see if our unit tests pass or fail. So I will make these slides available on Blackboard. Some resources here for you. So what we're going to do in class is kind of a hybrid. There's a 4-part tutorial series from Visual Studio Magazine. I've posted the links in Lesson 10 on Blackboard, so you can go through that. There's also this 1-hour video tutorial here where this developer does a pretty good job of explaining how to implement mock framework into a .NET MVC application for unit testing. So our lesson takes kind of a hybrid of these two tutorials, one that's text-based and one that's video-based. So I'll leave these here as a resource. Here's the link to the mock NuGet package that we're going to use eventually. And also some basic slides here so that your notes are here. So these are some screen captures I've taken from that video tutorial, and we'll come back and refer to this in a little bit. So let's have a look. We'll get our music store running. I've got our music store running in the browser. Now, we won't actually see any changes to the front end of the music store today, other than we're going to wind up disabling a bunch of our controller code and then rewriting it, refactoring it, and adding it back in slowly over the next couple of lessons. Okay. So we actually have some unit tests already. When we set up our project, we added it. We enabled the unit testing option. That's why our solution has 2 projects, our main web application project, and then we have our unit test down at the bottom. And in here, we actually have a controller called the home controller test class. So it has references to Visual Studio's unit testing tools, and it references the controller's namespace of our web project. So we have a home controller in our web project. I'm going to close all my files except this one. So notice this file was auto-generated. So we have 3 methods: index, about, and contact. And these mirror the index, about, and contact methods we have in our home controller. And you notice each one of these methods has a test method. So we know code is for unit testing only, as well as our entire controller has this test class annotation at the top. Let's have a look at how these unit tests work, and then we can actually try to run them. So our index test, it creates an instance of our home controller. So this is our arrange. So our arrange step is setting up everything we need in order to execute the test. Our second step is what we call acting. So this is where we actually execute the piece of code we want to test. So in this case, we're calling the index method. We expect to get a view result, and we're going to get a view result back. And this is our assertion. Now we're going to check that the result of our action is what we expect. So in this test, all we're checking, it's probably not the best unit test, this is just checking that we get a view result coming back from the index method. Now, this doesn't make sure we're getting the proper view coming back, but it is making sure something is coming back, and what comes back is a view result. So here's our about method. It's similar. Again, we're going to instantiate our controller. We call the about method, but this time we're doing an assertion. We're checking that the view bag message in our result is equal to your application description page. And for our contact, again, same as index, we're just checking that we get a view result back. We can actually run these tests. You click on test and run all tests. It's going to open a window over here called the Test Explorer. So it opens it up. And if we expand, notice our contact and index tests, those passed. So in each one of these, we were checking that we got a result back that was not null. So for index, that worked. And for contact, that worked. But for about, it failed. Why did about fail? Let's have a look. So if I click on the test, I get a description. So our unit test was expecting the message, your application description page, which when we built our application by default is what our about method says. But when we go to our home controller and look in the about message, we changed back in week 2 or week 1, we actually changed the view bag message. So our method puts this value, some content about us, in the view bag, but our unit test is looking for your application description page. So in order to get our unit test to pass, and notice Visual Studio actually shows me this method has one unit test, it's run, and it did not pass. So to change that, if what we expect to get back is some content, this has to match exactly, there's no period here. So now if I save this, I can either rerun all the tests again, I can run the failed test, or I can just run the selected test. So I just want to run about again. So rebuild my solution. And now all our tests pass because our test is checking this, we get this value, and that actually matches the result from our view. So this is the general idea of how unit tests work. We also have now, if you have the professional or enterprise edition of Visual Studio, we have this other tool. If not, I'm going to show you a package you can use instead. You have the community edition. So if you go to help and about, in this little pop-up window, it'll tell you if you have community, enterprise, or professional. So what I'm going to show you right now is a tool that you don't have access to if you have the community edition, although there is an add-on we can add, which we'll talk about in a minute. So if I click on test, go to analyze code coverage for I can pick all tests. It's going to rebuild my solution. Then it's going to pop open a window. So it'll tell us in our entire project, here are all the code blocks, 97% of which are not covered. So the only things that are covered by unit tests are these 3 methods. We can actually see this if I expand my music store project and then go to controllers. So our home controller is 84% covered. Okay? So there are 5 blocks of code in the home controller that are not covered. So normally when we're unit testing, we want to get as close as we can to 100% coverage. So for example, our albums controller is 0% covered. So we're going to start, and over the next 2 classes, we're going to get as close as we can to 100% coverage in the albums controller. So you can actually drill down here. And the reason we're not, so it says about and contact each have 1 uncovered code block. Index is fully covered. And we added this extra method. So this is from my afternoon class. Here in the morning class, we wrote another method in here in our home controller. But we have no unit test at all. So I've also got this little neat code coverage coloring. So if I click that and I go into my home controller, wherever I see something is blue, so my index method, that means this method's covered. This is covered by a unit test. So notice my index is at 100% coverage. In about, so we are checking the view bag message, but we have no check that we are returning the view called about us. And then same in our contact, we're checking. So we only have partial coverage. And for our gallery, we have nothing. We have no check. So if we want to write a couple quick unit tests in our home controller, we can increase this code coverage in this controller from 84%. I'm going to go back here. Create a test method. So we're going to arrange controller. We'll create an instance of. Call our controller gallery method. Expect to get a view result back, and then we can insert. And we'll just make sure the result is not empty, not the world's best unit test. Now it'll tell us that this test here, we've got a blue mark indicating this unit test has never been run. So if we execute it, we should see the 0 here, and my code coverage is going to increase as well as our overall code coverage in the controller. We're going to run this. My test passed. Unfortunately, this window, there's no refresh button, which is super annoying. So I got to run my code coverage again. So if I drill back down, so we've increased overall from about 2.5% to 3%. I go back to my home controller. Now notice we're up to 93% and our gallery method is completely covered. So we're not quite at 100%. So for contact and about, we're checking the view bag, but we're not checking that our result actually is not null. And for contact, we're checking the opposite. We're checking the result, but we're never actually checked the view bag. We could actually write a couple more methods and see if we can get a little closer here. Contact view bag. We start our test names with the name of the method we're calling and then a description of what is it we're checking. Launch. And we'll create an instance of our home controller. Back. Back method to give us a view result. And then we can assert the view bag message. Here, make sure it's a capital M, is your contact page, period. So we're checking that the value in our view bag is equal to your contact page with period. Build. And then we will run and check our code coverage one more time. So all of our tests have passed. We're up to 4% code coverage now. And if we go back to the home controller, notice now our contact went from 92% to 100%. I turn my code coloring back on. Remember, our contact method previously was partly yellow, partly blue. Well, it's all blue now. So we've completely checked. So with one more unit test for about, we only have one uncovered block. We can get to 100% here. So we're checking the view bag, but we're never actually checking that we get a view that's returned. And this one, we can actually check the name of the view that's being returned. So we'll do that. So maybe underneath our home, or underneath our first about, go write one more. About loads view. Repeating the same array statements, we can make this global in a bit, rather than repeating the same object that we're using over and over again. Act. About method. You want to check what we're expecting is a view name called about-us. And what comes back is a result view name. We want to make sure that this value is equal to the name of the view that comes when we call the about method. Save. We can just say for the selected tests, run these and check the code coverage. And now our home controller, we're now at 100% coverage. I'm not quite sure why these are still showing as yellow. So all the blocks, we've now tested every single thing that happened. So we have 4 methods and we needed 6 unit tests to properly test for everything. So what we want to do is we want to start writing unit tests in our albums controller. It's going to take us a couple of classes. If we open up the albums controller, basically it's all red. Nothing in here is covered by any unit tests. Okay. So we have all of these methods, 2 versions of create, a get and post, delete, get and post, details, dispose, which we're not going to worry about, edit, 2 versions, get and post, and index. So we need to unit test all of these methods and then all of the different options inside. So for example, if we look at the index method, let's look at a couple of these. In our index method, we're going to need 2 unit tests because 2 things are happening here. The first one is we're writing a query to fetch the list of albums. Second thing that's happening is we are returning a view and passing that data to it. So we're going to want 2 unit tests, one to check that we get a view called index, and second, that the model for that view is a list of albums. If we look at details, we really have 3 possibilities. First possibility is we've called details, but we have no ID. In this case, we want to throw an error. Then we have 2 possibilities if our ID is not null. The first one is we query the database, but we do not find a matching album. In this case, again, we're throwing an error. The last scenario is we find a matching album, we load the view and return that. So we need 3 or 4 unit tests here. I'm actually going to put this list on Blackboard in a bit. So if we're going to unit test our albums controller, here's pretty much the list. So we're going to need about 24 unit tests. And in your assignment, you're going to need to unit test one of your controllers. And however many of the tests we can get through this week and next week, that's the number of unit tests you're going to need in your assignment. So I'm going to actually just copy this to Blackboard now so that you have a full list. So this list will be in the week 10 unit testing part 1 folder. And this is one video for both sections of the Friday class, so it should be in both the morning and afternoon sections. of week 10. Okay, so let's go and create an albums test class down in our unit test project, and we can try writing some basic unit tests. So down here in controllers, I'm going to click add a new item. And I'm going to go into test. And I'm just going to pick a basic unit test. We'll say an empty unit test declaration. And by following convention, I should call it albums controller test. So exact same name as my albums controller with the word test on the end. By the way, I forgot to mention, if you have the community edition, you don't have this analyze code coverage. So there is an extension you can install for Visual Studio. It will require a restart if you go to Tools, Extensions, and Updates and click Online. If you search for the word cover, this AXO cover plugin is a free .NET code coverage support for Visual Studio. If you click on this, you can download and install it, but you will get a notice that it will not install until you restart Visual Studio. So you want to close Visual Studio. Once you do, you'll see a little window pop up in the taskbar. You click that, run the installer, and then you can reopen Visual Studio. And then you'll get it's a similar code coverage tool to what we had. I guess I can actually install it and we can look at it. I haven't used it personally. I know some students in the Monday section use this. So it says changes will begin when Visual Studio windows are closed. So I'll close my project. And now, given a second, my Visual Studio installer is going to start. I'll click Modify. Said I haven't used this tool before, but we can see it maybe it's better than the built-in code coverage tool. Okay, so now I'm going to open Visual Studio and my project back up. I think so far we haven't done anything too complicated. The complex part is going to come next. Open my project back up. I'm going to need to get it launched again. I'm going to uncheck this. So I can actually, maybe I'll open up this AXO cover tool and we'll let it run. We'll see. So it's actually got a visual, 6 tests, none have passed. So if I run my tests from here, so it actually runs the unit tests here. And if we'll click on cover, we'll see what it shows us. So it does give us a little report down here. You may have to look through a little bit more. I'm sure there's a way to see a better code coverage, but we'll have to explore it. Okay, so I'm going to launch my debugger. Sorry, my server without my debugger. So notice this new test does not run, it's blue. So we're going to rename this test to index view. This is going to test that when we call the index method of our albums controller, it properly loads view. Index. Now, I could in here, well, I guess we'll do it once. So we'll change our albums controller equals new albums controller. Notice we get an error here. The reason is our new test class has no reference to our web project controllers. Our home. We're going to need this reference. So I can just use Visual Studio to generate the reference. Okay, I'm surprised at not getting a code prompt. That's okay. So using my solution, my project name controllers. That goes away. I want an act. Index. We're getting an error here as well. And the reason is, it doesn't know what a view result is. So we need to make another reference. So we need a reference to system.web.mvc. Our error goes away. So again, this was automatically generated in the home controller test. So lastly, we want to assert. First, we'll just check that our result is not null, and we'll change that. Assert, the result is not null. So let's run this unit test and see what happens. I don't need to run my home controller test, I just want to run this one. So our unit test, which we would have expected would probably pass, our test actually fails. Why? Our unit test is actually looking for a connection string called default connection. And our unit test project has an app.config because this is not a web project. So it's saying, well, there's no connection string here because this is being called from a separate project altogether. It doesn't read our database connection string. Well, why is this using the database at all? Let's go back and look at our albums controller. Remember, we scaffolded this controller and notice right here, so our test fails. The first thing that happens when we create an instance of our controller is it connects to our database. So in order for this to work, we would need the database connection string here. Now, we could do that. That would solve our problem. But the issue becomes then, we don't have a true unit test in this case. If our controller is connecting to the database, it's now running integration testing between our web project and our database. The whole idea of unit testing is we're trying to divorce the database from the unit tests temporarily. So to do this, we're going to have to refactor or rewrite some of the code here because this automatic database connection that happens every time our controller runs, we no longer want that to happen. So I'm going to just jump down. These slides are on Blackboard here in this controller unit testing, and it's based on this video. I want to explain how we're going to do this. Right now, this is the way our scaffolded controllers work. As soon as we load an instance of our controller, It connects to our database context, which uses Entity Framework to connect to SQL Server. So this is tightly bound. Soon as this controller loads, it connects to the database. So this automatic database connection, we're going to need to disable this. So what we want to do is we're going to put a layer or an interface in between here. So our controller, instead of calling the database automatically, is going to go through this interface instead. The reason we're going to do this is when our application runs in the browser, we still need the controller to connect to the database, but we also have a scenario where we're unit testing where we don't want the controller to go to the database. We want the controller to work with some in-memory, some fake data instead. So in that case, which is what we're trying to do now, when we instantiate our controller, we want it to go to basically a fake place and just work with pretend data, and we don't want it to connect to the database. So we now have two scenarios. Our application's running in production and needs to integrate with the database, or we're unit testing, where we're faking the database. So these slides come out of this video tutorial. So ultimately, our controller needs to be able to take two different paths. When it's running in production, its default behavior, it will go to one repository which connects to the database and works with our SQL Server. However, if we're unit testing, we just want a second interface or repository that will work with our mock data instead. So to do this, we're going to use a technique called dependency injection. The way this works is every time we call on our controller, we're going to pass something to this controller. If we pass some mock data to the controller, we want the controller to take this path. If we pass nothing to the controller, we want it to take this path and use the database. So every time we create an instance of the controller needs to know, do I have mock data to work with? If so, don't use the database. If I have no mock data when I get created, then I'm going to need to connect to my database. So we're going to have to rewrite or refactor most of the code in our controller. So here's what we're going to do. First thing we're going to do is we are going to disable automatic connection. I'm going to comment on 17. Notice when I do this, I'm going to break all our methods. Suddenly, this database doesn't necessarily exist. So what I'm actually going to do is comment out most of the methods here, except for index. So I'm going to temporarily comment out from line 26 from my comment on get details. I'm going to basically comment out everything in our controller. And we'll slowly put this code back in one method at a time as we refactor it over the next couple lessons. I'm commenting out, as you can see, basically everything except the last two curly braces. Comment all those out. So we have two curly braces, but all our other methods are now commented out. So now what we need to do, I'm just going to save this, we're going to come back here, but we need to make these two repositories, the one that works with mock data and the one that works with our live data. So I'm going to go to my models. I'm going to right click. I'm going to add a new item. And under code, I want an interface. I'm going to call this, first we'll make our mock one, I. I'm going to make this public. And we're going to basically list of albums. That we can read, so it has a get method. Make a fake save method that will actually handle both inserts and updates. A fake delete method. Remember, this is just for unit testing for mocking. So we've made our albums repository for doing unit testing. We now need an albums repository to connect to the database. So we're going to move our database connection out of the controller and into a second repository. I'm going to make an add, in this case, a class. So this one I'm going to call albums. So that's our entity framework, the albums repository that actually connects to the database. We've got one that's mocked and one that will still use our database. Here, this is going to use the mock as a template. Notice when I do this, as well, if we're basing this class on this interface, well, this interface needs a list of albums and a save and a delete method. So we can write these ourselves, or we can just choose implement. And now it grabs from the parent interface the list of albums and writes a delete and save method. So we're going to rewrite these instead of a not implemented. Here's our get method. This is where we'll query the database. We'll do our query here instead. And notice doesn't know what our database is. So we're basically moving our database connection from here to our mock repository. Our database connection no longer happens in the controller. It happens in this repository. This repository doesn't use the database because it's all in-memory data. So for delete, I'll remove, save. Our save method here, we can run both the insert and update inside of this one method. And just check for album ID. If our album ID is 0, add a new album. Otherwise, we just basically mark the album state as modified. Here we're inserting. And then we'll call save changes. And lastly, this expects to return an album. We just return the album object back. So our code for interacting for the database has actually become much more lightweight. We can do all our CRUD operations through this interface. Get a list of albums, which from here we can then get a single album, and then delete and save. So now our controller code, when we call our controller, we now need to write this logic. So when our controller gets created, are we taking this path with mock data, or are we taking this path? So here's how we're going to do it. We're going to set up two constructors. The default one so first we need, instead of our automatic database connection, we're now going to use this DV variable to represent our repositories instead. When our controller is created, we have to determine which repository are we using. In this case, if nothing is passed in, we're going to use our framework repository, the one that actually connects to the database and has full save and delete methods. If, on the other hand, we get a mock object passed in, DB is not actually using Entity Framework. It's going to call this repository instead that just works with the fake in-memory data. So depending on which one of these we're passing, if we pass nothing, this is the default path. We're going to use the live database. If mock data is passed in, instead of the real database, we're just going to use the mock data. Now, our controller can take our unit testing path with a mock repository, or it can take our live path. So now if we build, our code succeeds, I'm actually going to temporarily comment out this code. First, we just want to check if this actually loads anything. It's going to return a view. That's all we want to check for now. So now I'm going to go all the way back to my album's controller test. Now we should be able to run this, and this error about our database connection not happening. Well, actually, we're not quite there yet. I think if we run it, it's still going to fail. We'll try. I think we're still going to get this error right now. Actually, our index test does pass. So now that our controller does not automatically connect to the database, our view passes. So it does return a view, but is it returning the right view? So instead of just checking that it's not null, let's check the name that comes back is index. And this matches our result view name. Let's run this again. In this case, our test failed. So we expected to get back index, but we actually got nothing. This result.view name is empty somehow. There's an easy fix for this. we just, in our return statement, if we're explicit about the name, we didn't really need this to load the view when we're running in production, but for our unit test, we'll actually have to specify the name of the view. So now if we run our test again, our test passes. So in all of our return view statements, we're going to need to explicitly define the name of the view that's being returned. So a little extra coding, that's okay. That makes sure our unit test is more accurate. Because it's not really, we don't just want to check that we get any view back. We want to make sure we're getting the correct view and that that view is called index. So that's one of our two tests, and that's correct. Now we need to deal with our data because we've disabled, in effect, the query part. So this is where our mock data needs to come in. So what we want to do is we're going to need to install a NuGet package. So we're going to install this package. Link is on Blackboard. So this is extremely popular. You can see how often it's downloaded, almost 1 million times. And some months over 1 million downloads, for each version. It's a very popular package. So I'm going to click on Tools, NuGet Package Manager, and Manage NuGet Packages. Make sure you click on Browse. I'm going to search for mock. So we want mock. I don't need to install it in the Music Store web project. I need it in the test project. Excuse me for a minute while I yell at the dogs. La, shut up. I'm going to click Install. Accept. Again, we're installing this in the unit test project. I'm going to say yes to all. And I can close my NuGet Package Manager. So now what we want to do, we're going to do a couple things. We're going to create some mock data in our controller. And then when we call the controller, right now it's still, we're not passing anything in. So it's taking this version and looking for the database. We want to pass it in mock data so that it goes on our mock path instead. So here's what we're going to do. So we're going to do mock. In here, we're going to declare a few things globally. I could declare them inside of this index method, but we're going to need them for all our unit tests, so it's easier if we declare them up above. First thing we're going to do is we're going to declare our controller here. Now we want to create an instance of our iAlbums mock. Notice Visual Studio doesn't know what this is. Remember, this is built in our models namespace. You can see models in the path. So we've got to reference our models folder. Let's accept the reference. The last thing we're going to create is a list. Albums. Again, doesn't know what a list is. Prompts us to make a reference to system collections.generic. This should be, list of album. So we've added these references, mock, models, and system.collections.generic. So I use Visual Studio to generate the references. You can add them manually. Now, Visual Studio test classes, they also have a test initialize method that will run automatically before every unit test. So we want to create the controller and set up our mock list in there so we don't have to do it in every single one of our unit tests. I'm going to comment this line out. I'm going to create a test, initialize. This method automatically for each individual test. So in here, we'll want to instantiate these items. So our controller equals a new albums controller. Whoops, sorry, we'll do this. We'll come back to this. We need to set up our mock first. We're going to create a new mock object. With albums mock. Create a new mock data object. Populate. We've created this list up here called albums. We're going to populate it. Window for a minute. We'll create some fake albums. We're going to need artist property. We're ordering our list by the title and then the artist name. I'm going to make this stuff up. Whoops. My artist equals a new list. Just need this in here so it knows it's a number. I'm just going to copy this twice and change the values. Final comma. Showing. This will be artist ID. We're just faking this stuff. There's our fake list album IDs 100, 200, 300. So we've created this list. We now need to populate our mock object through the list. our mock has a setup method. Our albums, it will return to us a queryable list. Notice it says queryable isn't recognized. You can see we've got a reference here. So if we use system.link, add a reference to system.link, we can make our list queryable. So we can sort it, we can filter it. Now is when we instantiate into albums controller, and pass it our mock object. So now when our unit test runs, it will automatically create a new mock object, populate it with this list, and call our albums controller. In this case, it's going to call this instance of our albums controller. When we pass in a mock object, we're no longer using Unity framework like we are here, but we're using our mock data. So let's just run this unit test again. I'll run my last run of the test. So our index view still loads. So now we need one more unit test here. We want to check that index returns albums. Not only does it load the view called index, but this view displays a list of albums. So we don't really need to arrange because that's now happening in the test initialize. We'll just act. What we want to make sure that we get a list of albums back. Call controller index model. So when we call our controller method, we get a view result back, and then the model should be a list of albums. We're calling, in this case, we're not checking two values, we're checking two lists. So instead of an assert, like we have on 163, we're using collection assert. We're checking our albums list is equal to the result that comes out of our method. So let's try this test and see what happens. We'll run it. Our test fails. So let's see, why did it fail? We can actually run this with the debugger. So if I put on a breakpoint and debug the test, we can step through it one line at a time. So here's our mock object is populated. We can see it. Got a list of albums. So what happens? We're returning a view called index, but notice we've commented out the data. So our result, in this case, is null. Right now, our index method is not passing any data back in the model. Our result is null, but our list of albums has 3. So these items aren't equal. A failing test is what we would expect. So we actually get an error because we were expecting to get back a list of albums and we didn't. So now we need to go back to our albums controller and put this back in. Rerun our query. We're putting it back in our return view, but again, we're keeping the name of our view. Let's build. And let's run our last run again. So what happens? Our index view loads, but these still are not equal. So we'll try it again with our debugger. So this time we're going to run our query. Now we have a list. We can actually look at this. So we've actually got a list of data here. So here's our result. We have 3 albums. Album ID 100, 200, 100, 300, 200. So we are getting the albums, but notice the result. Our album list is ID 100, 300, 100, 200, 300. So we actually have the right data, just in a different order. Our album list in our unit test is ordered by ID 100, 200, 300, but the result is coming back ID 100, 300, 200. Why? Because remember, our controller method is ordering by artist and then by album title. So we'll need to resort our list to pass the unit test. So in this test, now if our test is that they should be sorted this way, we should probably order them the same way. Actually, let's do it here. First by artist name. Let's try it this way and see if that fixes our problem. No, that still doesn't. try it here. Start the data. Okay, so we're close. We just have to get the sorting right. Well, maybe what I'll do to make sure they're in the right order is we'll actually put them in the order we want. We'll put them alphabetically. 300 should happen before 200. This is what we would expect them to be in this order. And we'll make artist ID the same in each case. So now the data we're passing is in the order we expect to get it back in. Yeah, we can take this out. So we've got 2 unit tests. We can actually look at our code coverage now. And if we look in the albums controller, we should have close to 100% code coverage because we've commented out most of the methods. So in my albums controller, we're at 91%. Our index method is fully covered. This constructor is fully covered. We're never going to be able to cover this constructor because this version is the one that uses the database. So we cannot cover this by a unit test, which is okay. But everything in our index method is now covered, that we have the data we expect in the order we expect, and we are loading the view with the correct name. So that's all we're going to do this week. So I know it's a lot of setup. So next week, what we're going to do is carry on with this list of unit tests and see how many of them we can write. So for details, we'll be checking null IDs, invalid IDs, valid IDs, and the correct view. Edit and delete will be pretty similar. Obviously, our post methods have some different unit tests we're going to need to take care of. So I will post all this code to GitHub, and we'll carry on next week. We will have a quiz on unit testing to start next week's class.